Do you ever feel like the future's just a total mystery? Well, what if I told you there's this secret language, a kind of code that lets you peek behind the curtain? It's used by forecasters, by scientists, by strategists to get a real handle on what's coming next. And today, we're going to crack that code together.
So it all starts with these symbols that honestly look like they belong to some kind of secret society. You've probably seen this one before. And yeah, it looks pretty complex, right?
Or, how about this one? What on earth could that mean?
And then you've got this one. Now this might be the most powerful of them all. You're going to want to stick with me because this is where things get really, really interesting. Okay, I get it. It looks super intimidating. But I promise you, by the end of this quick explainer, you're not just going to understand these symbols, you're actually going to be able to use them. So you ready? Let's start breaking this code down, piece by piece. You know, every language starts with an alphabet, right? Well, the language of chance is no different. We're about to learn the absolute ABCs of probability. These are the fundamental letters that are going to unlock everything else. All right, let's start with the big one, P of A. It looks all formal and fancy, but really all it's asking is, hey, what are the chances of event A actually happening? And A can be literally anything. The chance it rains tomorrow, the odds of rolling a 6 on a die, the probability your favorite team wins the championship. It's the starting point for, well, for every question we're going to ask.
And here is an absolutely crucial rule of this language. Every single answer to a probability question has to live somewhere on this scale. It's always a number between 0, meaning it is absolutely 100% impossible, and 1, which means it is a guaranteed certainty. Think about it. Everything that could possibly happen, from a simple coin toss to a complex weather forecast, fits somewhere along this simple line. Okay, but what about the things that don't happen? Well, probability has a symbol for that too. We use this little apostrophe, it's called a prime, to represent the opposite. So if event A is it rains, then A prime is simply everything else. It does not rain. It's literally the other side of the coin, and believe me, it is just as important.
All right, let's move on to our next symbol and see how this all starts to build. See this U shape? That's the symbol for OR. So P of A or B is just asking for the chance that at least one of these things happens. A great way to think about it is ordering food. What are the chances you'll have pizza or tacos for dinner? I mean, you'd be happy if you got pizza, you'd be happy if you got tacos, and you'd probably be pretty happy if you somehow got both, right? Okay, now what happens if we flip that symbol upside down? Well, this becomes the symbol for AND is a lot stricter than OR. It's not about one or the other anymore. Now it's all about the probability that both events happen at the same time, that perfect overlap. You can kind of think of it like trying to hit a really, really specific target. And that brings us to, honestly, the most powerful symbol in our entire alphabet, this vertical line. It means given. This is where we level up from just calculating chances to, well, to actually learning and updating our beliefs based on new information. It asks a powerful question. What is the probability of A given the fact that B has already happened? Think about it, right? The chance of rain dramatically changes if you look outside and see dark clouds rolling in. This little symbol is exactly how we captured that kind of change. Okay, so now we've got our alphabet, but just having letters doesn't make a language, does it? Nope. We need grammar. We need rules that let us string these symbols together to make really powerful predictive statements. First up, let's talk about the grammar for OR. This is also known as the addition rule. Now, before I even throw the formula at you, just remember it's one simple mission. It's all about making sure we don't count the same thing twice. That's it. That's the whole secret. And here it is, the rule itself. To find the probability of A or B, you just add the probability of A to the probability of B. But hang on, look at that last part. We then have to subtract the probability of A and B happening together. So why on earth would we do that? It's because if we don't, we've actually counted the overlap. That little sweet spot where both A and B happen, we've counted it twice. Think about it. We counted it once when we calculated P of A, and we counted it a second time in P of B. So the whole point, the crucial step, is that we have to subtract it once to get back to the true probability. Okay, next up is the grammar for AND, which is the multiplication rule. Now, this one seems really simple on the surface. To find the chance of both A and B happening, you just multiply their probabilities. But, and listen up because this is a huge but, this only works if the events are independent. And what that means is that one event has absolutely zero effect on the other. A classic example is flipping a coin and then rolling a die. The coin has no idea what the die is going to do. But if the events do affect each other, say like drawing 2 cards from a deck but not putting the first one back, well then this simple rule just doesn't apply. And that's a super important distinction to remember.
All right, theory is all well and good, but let's actually see how this new language works out in the real world. It is time for a field test. Let's put our code to the test with some classic, everyday examples.
Okay, let's take a regular old 6-sided die. What's the probability of rolling an even number? Well, first, how many possible outcomes are there? 6, right? 1 through 6. And how many of those outcomes are the ones we want, the favorable ones? That would be 2, 4, and 6. So that's 3 favorable outcomes out of a total of 6.
And of course, 3 out of 6, that's a fraction we all know. It's just 1/2, or 50%. And this is a perfect example of how this formal technical language of probability connects directly to the intuition we all use, like every single day. Let's try another one. You've got a standard deck of 52 cards. What are the odds of drawing an ace? Well, there are 4 aces in the deck, so that's 4 out of 52. Simple enough? Now, what about its complement? What's the probability of not drawing an ace? Well, that's just everything else, isn't it? It's the other 48 cards, so that probability is 48 out of 52.
So look, you've learned the alphabet, you've got the basic grammar down, you can officially read the language. But how do you get fluent? How do you make that jump from just solving problems on a page to actually thinking like a forecaster, someone who truly understands the dynamics of chance? Let's talk about mastery. Here's what you do. It's a simple but super powerful mental checklist I like to call the golden thinking method. Anytime you face a probability problem, just pause and ask yourself 3 questions. Number 1, is this an or problem? If it is, you know you're going to be adding, and you have to watch out for that double count. Number 2, is this an and problem? Okay, then you're going to be multiplying, and you better check for independence. And finally, number 3, is this a not problem? That's the easy one. You just subtract from 1. Seriously, this little checklist will guide you to the right answer almost every single time. And hey, as you get more and more confident with this stuff, just keep an eye out for these really common traps. First, don't just be a formula robot, okay? Try to understand why the formulas work. Second, always double-check if you're dealing with an and or an or situation. They're easy to mix up. And maybe most importantly, never forget to actually interpret your answer. A number like 0.75 isn't just a number, it tells a story about what's likely to happen in the real world. So always ask yourself at the end, so what does this actually mean? Because really, in the end, what we've done here today is way more than just math. You've actually learned a whole new way to see the world, a framework for thinking about uncertainty itself. So just remember this, probability isn't really about the numbers. It's about understanding and navigating the endless ocean of possibilities. If this helps you understand, don't forget to like and subscribe for more powerful concepts.